Most people think gemstones have a color. Green is green, red is red. And once a stone is cut, that color is supposed to stay the same forever. But that assumption is wrong, because some stones don't have a color. They respond to it. Under sunlight, they appear one way. Step indoors, and they become something else entirely. Not because they're treated, not because they're fake, but because light itself is changing, and the stone knows it. Today, we're counting down 15 gemstones that change color, stones that confuse scientists, fascinated collectors, and quietly obsessed Americans who notice something most people miss. This list isn't about price. It isn't about rarity. It's about what happens when reality shifts, and the object in your hand shifts with it. And somewhere near the top of this list is one stone that doesn't just change color, it changes how humans understand color itself. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 15th. Fluorite, the stone people think is fake. Most people don't believe fluorite can change color. In fact, many Americans don't even believe fluorite is a real gemstone at all. They've seen it in gift shops, on office desks, in cheap crystal displays glowing under neon lights. So when fluorite appears in a serious gemstone documentary, the reaction is almost always the same. That one doesn't count. And that misunderstanding is exactly why fluorite belongs on this list. Because fluorite doesn't change color in the dramatic, overnight way people expect. Instead, it changes color in a way that quietly exposes how little we understand about light itself. Under daylight, fluorite may appear pale green, icy blue, or even nearly colorless. But introduce a different light source, LEDs, incandescent bulbs, or ultraviolet light, and something subtle begins to happen. The stone doesn't just look different, it responds. Bands of color emerge, saturation deepens. Sometimes violet tones appear where none existed before, not because the stone is treated, not because it's artificial, but because fluorite's internal structure interacts with light in ways our eyes aren't trained to notice. This phenomenon is called fluorescence, and fluorite is the mineral that gave it its name. Scientists discovered long ago that certain fluorite crystals absorb invisible ultraviolet energy and re-emit it as visible color. That means the stone is literally converting one form of light into another, something most gemstones simply cannot do. And yet, despite this remarkable behavior, fluorite was dismissed. Why? Because it's soft, because it fractures easily, because it doesn't fit the luxury mold Americans were taught to value. But here's the twist. Fluorite wasn't rejected because it lacks beauty. It was rejected because it arrived too early. Long before modern lighting, ultraviolet lamps, and optical research, people simply couldn't see what fluorite was capable of. Its most dramatic transformations were invisible in candlelight. Today, that's changed. Collectors, optical engineers, and serious mineral enthusiasts now seek fluorite for reasons that have nothing to do with jewelry. High-purity fluorite is used in advanced camera lenses, telescopes, and even space exploration, because it bends light with extraordinary precision. In other words, fluorite didn't fail as a gemstone. It outgrew the category. And that's why it sits at number 15. Because fluorite represents the first step in this journey, a stone that does change color, but only for those who know how and when to look. So maybe the real question isn't whether fluorite changes color. It's how many transformations we've been ignoring, simply because they didn't happen loudly enough. Ranked 14th, Hackmanite, the stone that remembers light. At first glance, Hackmanite doesn't look impressive. In a display case, it often appears pale, lavender, grayish-white, sometimes almost dull. Nothing about it suggests drama. Nothing suggests obsession. And that's exactly the trap, because Hackmanite is not a stone you look at. It's a stone you activate. Expose Hackmanite to sunlight or ultraviolet light, and something unsettling begins to happen. The color deepens. Pink tones appear. Purple intensifies. In some specimens, the change is so sudden that people assume it's a trick. But the real shock comes later. Take the stone back indoors, remove the UV light, and instead of immediately reverting, Hackmanite stays changed. Minutes pass, sometimes hours, as if the stone remembers what it just experienced. This phenomenon is called tenebrescence, and Hackmanite is one of the few gemstones on Earth capable of it. Unlike fluorescence, which only exists while light is present, tenebrescence alters the internal electron structure of the stone. Light doesn't just pass through, it leaves a temporary imprint. For scientists, this raised questions that went far beyond gemstones. How can a crystal store information without electricity? How does light physically rearrange matter, then slowly allow it to relax back? For collectors in the United States, those questions translated into something simpler. Did that stone just change and stay that way? Hackmanite began appearing in mineral shows not as jewelry but as demonstrations. Dealers would place a stone under UV light, wait a few seconds, then hand it to a viewer. The reaction was almost always the same: disbelief, followed by silence. Because unlike dramatic color change stones that flip instantly, Hackmanite introduces time into the equation. It forces the viewer to wait, to observe, to question what they just saw. Historically, this behavior made Hackmanite difficult to categorize. It wasn't stable enough for traditional jewelry standards, and for decades, the technology needed to appreciate it simply didn't exist in everyday life. But modern America is built on controlled light. UV sterilization, LED lighting, screens, sensors. Suddenly, Hackmanite made sense. Today, high-quality Hackmanite specimens are sought not for brilliance, but for performance. Collectors value how strongly the color change occurs, how long it lasts, how repeatable it is. Because every time Hackmanite resets, it proves something quietly unsettling. That gemstones are not passive objects. They are systems. And Hackmanite doesn't just change color, it reacts, it remembers. Then, slowly, it forgets. After seeing this, people stopped calling it a trick. They started timing how long the color would last, as if the stone were deciding when to let go. Ranked 13th. Diaspore. The stone people don't trust. Diaspore is the stone people argue about, not because it fails to change color, but because the change looks too perfect. In daylight, Diaspore often appears cool green or olive. Under indoor lighting, it shifts, sometimes gently, sometimes unmistakably, towards champagne, rose, or soft pink. And for many viewers, that's the problem. That has to be treated. There's no way that's natural. Diaspore doesn't just change color, it challenges trust. Unlike stones that announce their transformation with dramatic contrast, Diaspore's shift feels curated, elegant, controlled. The kind of transformation people associate with technology, not geology, but Diaspore is neither lab-created nor artificially enhanced. Its color change is the result of trace elements, primarily chromium, interacting with different light spectra. Daylight emphasizes green wavelengths. Incandescent light pulls out warmer tones hidden beneath the surface. Nothing added, nothing removed. And yet, disbelief persists. That skepticism has shaped Diaspore's entire reputation in the United States. For years, it sat in a strange middle ground, too subtle for spectacle collectors, too controversial for traditional jewelers. When it began appearing in American jewelry stores, customers didn't ask about hardness or origin. They asked one question: is this real? The irony is that Diaspore's color change is actually more predictable than many famous stones. Given the same lighting conditions, it will behave the same way, again and again. What unsettles people isn't instability, it's precision. Diaspore doesn't feel emotional, it feels engineered, and that perception reveals something important about how Americans judge gemstones. We trust randomness, we distrust control. A stone that flips chaotically between colors feels natural. A stone that transitions smoothly feels suspicious. Diaspore exposes that bias. Geologically, it forms under high pressure in metamorphic environments, conditions that produce orderly crystal structures. That order is exactly what allows light to pass through in such a refined way. In other words, Diaspore's too perfect change is not evidence of manipulation. It's evidence of discipline. Today, collectors who understand this seek Diaspore not for drama, but for reliability. They evaluate how cleanly the colors separate, how balanced the tones are, how consistent the shift appears across lighting environments. Diaspore doesn't perform for the room. It performs for the observer, and that makes it one of the most misunderstood stones on this list. Because if fluorite taught us to notice light, and Hackmanite taught us that stones can remember it, Diaspore teaches a harder lesson, that sometimes when a gemstone behaves exactly as physics predicts, we're the ones who don't believe it. At this point, color change stops being a spectacle. It becomes a test of how much precision we're willing to trust. Ranked 12th, Scapolite. The color change almost no one notices. Scapolite doesn't announce itself. There's no dramatic flip, no instant shock, no moment where the room gasps. And that's exactly why it confuses people. Under daylight, Scapolite often appears soft yellow, pale lavender, or muted gray. Under warmer indoor light, those tones can quietly drift toward honey, rose, or faint violet. The shift is real, measured, repeatable, but most people miss it. Not because Scapolite doesn't change color, but because it refuses to perform. In the American gemstone imagination, color change is supposed to be obvious, a before and after moment, a transformation you can capture in a single photograph. Scapolite doesn't work that way. Its color change lives in the margins, at the edge of perception, where lighting, angle, and patience matter more than spectacle. And that subtlety has cost it recognition for decades. For a long time, Scapolite wasn't even discussed alongside color change gemstones. It was categorized as interesting but not exceptional, a stone for mineralogists, not collectors. Yet under controlled lighting, something remarkable becomes clear. Scapolite responds differently to light sources not because it contains dramatic chromophores, but because of how its crystal lattice filters wavelengths. Small changes in spectral balance produce noticeable but restrained shifts in hue. This makes Scapolite scientifically honest. It doesn't exaggerate, it doesn't hide. It simply reflects what light gives it. And that honesty creates a problem. Because viewers accustomed to theatrical transformations assume subtlety equals weakness. If a stone doesn't shout, it must not matter. But in laboratories and serious collections, Scapolite has earned quiet respect. Not for what it shows, but for what it proves. That color change is not a binary event. It's a spectrum. Most gemstones sit at one extreme or the other. Scapolite lives in between. And that in-between space exposes how crude our definitions really are. Is a gemstone only considered color-changing if the shift is obvious to an untrained eye? Or does it count when physics confirms a transformation, regardless of drama? Scapolite forces that question. For American collectors who move past novelty, it becomes a calibration stone, a way to train the eye, to learn how light, structure, and perception interact without exaggeration. In that sense, Scapolite doesn't exist to impress. It exists to educate, and that's why it belongs here. Because this list isn't just about stones that change color, it's about stones that change expectations. Fluorite taught us to notice light. Hackmanite taught us that stones can remember it. Diaspore taught us that precision can feel suspicious. Scapolite teaches something quieter and more uncomfortable, that sometimes the most real transformations are the ones we overlook. Nothing about Scapolite asks to be noticed. That's exactly why most people miss it. Ranked 11th, Iolite, the stone that taught humans how to navigate light. Iolite doesn't change color because of light alone. It changes color because of direction. Turn the stone slightly and blue deepens into violet. Tilt it again, and the same crystal fades into gray, sometimes nearly colorless. Nothing else changes. No new light source. No filters, just angle. This effect is called pleochroism, and Iolite is one of the clearest natural demonstrations of it on Earth. To modern viewers, that might sound technical. To ancient humans, it was survival. Centuries before compasses were reliable, Viking sailors crossed the North Atlantic guided by the sun, even when the sky was overcast. According to historical accounts and experimental archaeology, they used thin slices of iolite as a navigational aid. By rotating the stone and observing shifts in color and intensity, sailors could infer the sun's position behind clouds. Light polarized by the atmosphere revealed itself through the crystal. The stone didn't glow. It didn't react dramatically. It simply told the truth, if you knew how to read it. That's why Iolite earned the name Viking stone. But here's what most people don't realize. The same optical behavior that once guided ships now confuses gemstone buyers. Under one angle, Iolite looks like a rich sapphire blue. Under another, it appears washed out or dull. To untrained eyes, that inconsistency feels like a flaw. Why does it lose color? Is something wrong with this stone? Nothing is wrong. Iolite isn't unstable. It's honest. Its crystal structure absorbs and transmits light differently along different axes. What you see depends entirely on how the stone is oriented, not on lighting tricks or treatments. That makes Iolite uncomfortable in a market built on uniformity. Modern jewelry favors stones that look impressive from every angle. Iolite refuses that rule. It demands intention. Cutters must orient the stone carefully. Collectors must understand what they're seeing, and viewers must accept that beauty can change without warning. In the United States, that complexity kept Iolite in the shadows for years. It wasn't flashy enough for mass appeal, too unpredictable for mainstream luxury. But among serious collectors, Iolite quietly earned respect, not because it changes color dramatically, but because it teaches something rare. The gemstones are three-dimensional systems, not flat colors. When Fluorite showed us how light can be transformed, and Hackmanite showed us that stones can remember light, and Diaspore showed us how precision can feel artificial, Iolite shows us something deeper. That color itself is not fixed. It depends on angle, perspective, position. The same stone can tell different truths depending on how you approach it. And for a crystal that once helped humans cross oceans without maps, that lesson feels intentional. Because as this list moves forward, the stones ahead won't just change color more dramatically. They'll challenge something even harder to accept. That perception, like navigation, has always depended on how we choose to look. Ranked 10th, color change garnet. When curiosity turns into obsession. For most people, garnet is predictable. Red, dark, classic. The kind of stone associated with antique rings and winter jewelry. That assumption is exactly why color change garnet feels so disruptive. Under daylight, certain garnets appear cool, bluish-green, teal, sometimes almost gray. Bring them indoors under warmer light, and the color doesn't merely shift. It reverses. Green becomes red. Teal turns wine-colored. In high-contrast specimens, the transformation is sharp enough to make viewers question whether they're looking at the same stone. Unlike earlier entries on this list, color change garnet doesn't ask for patience. It doesn't whisper, it flips. And that instant clarity is what pulled American collectors in. When color change garnets first began circulating in the U.S. market in the late 1990s, they were often compared unfairly to Alexandrite. The question wasn't what are they, it was how close do they get. That comparison did two things. It elevated interest, and it ignited obsession. Because color change garnet offered something Alexandrite often couldn't, availability. While fine Alexandrite remained locked behind extreme rarity and price, color change garnets appeared just often enough to be chased. Collectors could hunt them, compare specimens, argue about thresholds and contrast. The obsession became measurable. In American gem circles, people didn't ask if a garnet changed color. They asked how much, how green in daylight, how red under incandescent light, how clean is the transition, how balanced are the tones. This wasn't novelty anymore. It was evaluation. Scientifically, the phenomenon is driven by a mix of trace elements, primarily chromium and vanadium, interacting with different lighting spectra. Daylight emphasizes shorter wavelengths. Indoor lighting pulls warmth forward. The crystal doesn't choose sides. It reveals both. And that duality resonated deeply with collectors. Because color change garnet sits at a perfect psychological intersection, dramatic enough to impress instantly, accessible enough to pursue seriously. It wasn't misunderstood like Fluorite. It wasn't doubted like Diaspore. It didn't require training like Scapolite or Iolite. It rewarded attention immediately. And that immediate reward changed behavior. Collectors stopped asking, is this real? They started asking, can I find a better one? That's the moment curiosity becomes obsession. Color change garnet didn't just introduce Americans to visible transformation, it introduced competition. And once that switch flips, once people begin comparing stones instead of questioning them, there's no going back. Because from this point forward, the stones on this list won't just demonstrate color change. After this, collectors didn't ask if it changed color anymore. They asked how far the transformation could be pushed. Ranked 9th. Color change sapphire, luxury that refuses to stay one color. Sapphire is supposed to be stable. For generations, Americans were taught that sapphire meant one thing: a deep, reliable blue, unchanging, dignified, permanent. So when a sapphire shifts color, it feels almost wrong. Under daylight, a color-changed sapphire may present itself as blue, blue-green, or even steely gray. Bring it indoors, under warmer incandescent light, and the tone slides toward violet, purple, or muted plum. Not abruptly, not theatrically, but decisively enough that no one mistakes it. This isn't novelty. This is luxury doing something it was never supposed to do. And that contradiction is exactly what captivated American buyers. Unlike color change garnet, which invites comparison and competition, color change sapphire invites hesitation. People don't rush toward it. They pause. Because sapphire carries expectations. It's associated with engagement rings, royal symbolism, and generational inheritance. A sapphire that refuses to stay the same color challenges all of that. Which color do you pass down? Which version becomes the memory? Scientifically, the answer lies in trace elements: iron, titanium, and sometimes vanadium, interacting differently with varying light sources. Daylight emphasizes cooler wavelengths. Incandescent light brings warmth forward. The crystal structure doesn't break. It reveals layers. But culturally, that explanation isn't enough. For many American buyers, color-changed sapphire creates a subtle discomfort. Luxury in their minds should be dependable. A stone that transforms feels unpredictable, almost rebellious. And yet, that unpredictability is what made it desirable. High-end collectors began to view color-changed sapphire not as a defect, but as refinement. A stone that could move between identities without losing authority. Blue when formal, purple when intimate. One gem, two roles. That duality made color change sapphire a quiet favorite among collectors who had already seen everything. It wasn't loud enough for spectacle buyers. It wasn't rare enough to intimidate newcomers. It sat in a narrow, powerful space, recognizable, respected, and quietly unconventional. Unlike earlier stones on this list, color-changed sapphire doesn't beg for explanation. Its shift is subtle enough to feel intentional, almost curated, which is why jewelers often hesitated to market it aggressively. You don't sell this stone with shock. You introduce it with restraint. Because the moment someone notices the shift on their own, something changes. They stop asking what sapphire is. They start asking what it can be. And that question reshapes how people relate to gemstones entirely. If color change garnet turned curiosity into obsession, color change sapphire does something more dangerous. It turns certainty into doubt. Here, permanence stops being a promise. It becomes a choice, depending on where the light comes from. Ranked 8th. Zultanite, when a name changes everything. Zultanite didn't become famous because it was discovered. It became famous because it was named. Before the name existed, this stone was simply Diaspore, known to mineralogists, quietly cataloged, rarely discussed outside academic circles. Its color change was real but understated. Greenish tones in daylight, warm pinks and champagnes under indoor light. Interesting, but not irresistible. That changed the moment the stone entered the American market under a new identity. Zultanite. Suddenly, the conversation shifted. The color change didn't become stronger. The physics didn't change, but perception did. Collectors began asking different questions, not about chemistry or structure, but about origin stories. Limited sources, exclusive supply, controlled branding. Zultanite became a case study in how Americans respond to gemstones when narrative arrives before knowledge. And the response was immediate. Jewelry buyers who had ignored Diaspore now leaned closer. They rotated the stone under light. They waited for the shift. And when the color moved, softly, elegantly, they believed they were witnessing something rare. They were. just not in the way they thought. Scientifically, Zultanite behaves exactly as Diaspore always has. Trace chromium interacts with different lighting spectra, producing predictable changes between green and warm hues. Nothing artificial, nothing enhanced. What changed was context. By controlling how the stone was introduced, where it was sold, how it was described, what language surrounded it, Zultanite became desirable in a way raw Diaspore never was. This unsettled purists. Some dismissed it as marketing theater. Others argued that branding cheapened geology. But collectors didn't care. Because for many American buyers, gemstones are not just objects. They are experiences. Zultanite delivered one. It invited people to participate, to test lighting, to compare environments, to notice differences in real time. Unlike color change Sapphire, which demands patience and restraint, Zultanite rewards curiosity quickly. The shift is visible. The tones are flattering. The transformation feels personal. Daylight in the office, warm light at home, the same stone, two moods. And that emotional responsiveness is what made Zultanite so effective. It didn't challenge luxury the way Sapphire did. It didn't invite competition the way Garnet did. It felt approachable, which is precisely why it spread. In American gemstone culture, Zultanite occupies a strange but powerful space. It's neither misunderstood nor intimidating. It's familiar, yet surprising. But beneath the branding, the stone tells a quieter truth, that the line between discovery and desire is thinner than we like to admit, that sometimes what we value most isn't rarity or performance. It's the story we're given permission to believe. Zultanite doesn't hide its science. It simply lets narrative walk in first. So what are we really responding to here? The physics of the stone or the story that arrived first? Ranked 7th. Color change Tourmaline, the stone that refuses to behave. Tourmaline has never been a disciplined gemstone. Where Sapphire is orderly and Garnet is decisive, Tourmaline is unpredictable by nature. It forms in complex chemical environments, accepts a wide range of trace elements, and expresses color with almost reckless freedom. So when Tourmaline changes color, it doesn't do it cleanly. It does it personally. Under daylight, a color-changed Tourmaline might appear green, teal, or bluish. Move it under warmer light, and the shift can lean toward pink, violet, or brownish rose. Sometimes the change is smooth. Sometimes it's uneven, one side responding faster than the other. Collectors notice that immediately, because Tourmaline doesn't flip like a switch. It transitions, and that transition exposes everything. Inclusions, zoning, growth history, nothing is hidden. Scientifically, this behavior comes from Tourmaline's complex borosilicate structure and its willingness to incorporate elements like iron, chromium, and manganese in varying proportions. Different light sources emphasize different absorption bands, and the stone reacts accordingly. But unlike more polished color-change gems, Tourmaline doesn't resolve into a single alternate identity. It explores. That exploration is exactly what divides American buyers. Some see inconsistency, others see character. For decades, Tourmaline's reputation suffered because it didn't conform to expectations. Jewelers prefer stones that behave the same way every time, under every light, from every angle. Tourmaline refuses that contract. Yet among serious collectors, that refusal became its appeal. Color-changed Tourmaline isn't evaluated by how dramatic the shift is. It's judged by how honest the transition feels, how naturally the colors move, how much of the stone's internal story is visible during the change. In the United States, this created a niche obsession. Collectors began seeking stones with visible zoning, where different sections respond differently to light. They rotated gems slowly, not to trigger a before and after moment, but to watch the color travel. That behavior tells you something important. Color change Tourmaline doesn't reward impatience, it rewards attention. And that makes it deeply human. Where Zultanite succeeded by guiding perception with narrative, Tourmaline invites interpretation. Two people can look at the same stone under the same light and describe it differently. Neither is wrong. That ambiguity unsettles casual buyers, but it fascinates seasoned ones. Because once you accept that a gemstone doesn't owe you clarity, you stop asking what it is. You start asking how it behaves. Color change tourmaline lives in that behavioral space. It doesn't simplify itself for the viewer. It asks the viewer to slow down. And in a culture trained to chase instant transformation, that request is radical. By the time American collectors reach this point on the list, something has already shifted. They're no longer impressed by color change alone. They're intrigued by complexity. This stone never settles on a single answer. It waits to see how much attention you're willing to give. Ranked 6th, color change Spinel. The collector's quiet obsession. Spinel was never meant to be dramatic. For centuries, it lived in the shadow of other gems, mistaken for ruby, confused with sapphire, overlooked because it behaved too well. Spinel didn't crack easily, it didn't cloud, it didn't demand attention, and that discipline is exactly what makes color change Spinel so dangerous. Under daylight, fine specimens appear cool, bluish-gray, slate, sometimes steel blue. Move them under warmer indoor light and the color tightens, sliding toward violet, purple, or muted wine. The shift is clean, contained, almost restrained. No chaos, no theatrics. Collectors notice immediately because Spinel doesn't perform. It complies. Scientifically, color change Spinel owes its behavior to trace elements like chromium and vanadium interacting with different light spectra. But unlike tourmaline, Spinel's crystal structure is orderly. There's no zoning, no internal argument. When the color moves, it moves as one. That unity is rare. And in the American collector market, rarity isn't just about how often a stone appears, it's about how reliably it behaves. Color change Spinel became a quiet benchmark. Collectors didn't chase it for spectacle. They compared it against everything else. How crisp is the transition? How neutral is the daylight tone? How saturated is the indoor shift without turning muddy? These questions don't excite casual buyers. They attract specialists, which is why color change Spinel never went mainstream. It didn't need to. In private collections, Spinel earned a reputation for honesty. No branding theater, no exaggerated claims. Just a stone that does exactly what physics says it should, every time. That predictability carries weight. Because after tourmaline's personality and Zultanite's narrative, some collectors wanted relief. A stone that wouldn't argue. A transformation that could be trusted. Color change Spinel offered that trust. It doesn't challenge luxury like sapphire. It doesn't invite obsession like garnet. It doesn't confuse like tourmaline. It reassures. And that reassurance changes behavior. Collectors stop rotating the stone anxiously. They stop second-guessing lighting conditions. They stop wondering whether the change is real enough. Spinel doesn't ask for belief. It earns it. That's why color change Spinel sits here, at the edge between fascination and discipline. It marks the moment when collectors stop being impressed by transformation and start evaluating control. Because from this point forward, the stones ahead won't be content to behave well. With Spinel, doubt disappears quietly. Not because the stone explains itself, but because it never needs to. Ranked 5th. Sphene. When color isn't the most dramatic thing. Sphene doesn't announce its color change. It distracts you before you even notice it. Under daylight, fine sphene can appear yellow-green, olive, or warm golden. Shift the light, move indoors, warm the spectrum, and the hue subtly leans toward amber or brownish-green. The change is real, but most people miss it, because something else happens first. Light fractures. Sphene bends light so aggressively that the eye struggles to focus on color at all. Rainbow flashes erupt along facet edges. Spectral fire competes with hue. Your brain prioritizes motion and brilliance over tone. This effect, called dispersion, is among the strongest in any natural gemstone. Stronger than diamond, stronger than sapphire, strong enough to overwhelm perception, and that's where Sphene becomes disruptive. Most color change stones ask you to compare. Daylight versus indoor light, cool versus warm. Sphene interrupts that process. It forces the observer to choose between what they see and what they're trying to measure. Collectors notice this immediately. Under one light, the stone throws greenish flashes. Under another, the body color warms, but the fire intensifies, scattering attention. The color change is happening, but it's fighting for relevance. That conflict is not accidental. Sphene's crystal structure, rich in titanium, creates extreme refractive behavior. Light slows unevenly inside the stone, splitting into vivid spectral components. Color doesn't disappear. It gets crowded. And that crowding changes how Americans respond to it. In the US market, Sphene never became a mass obsession, not because it lacks beauty, but because it resists categorization. Is it a color change stone? A firestone? An optical anomaly? The answer is uncomfortable. It's all three. Jewelers often hesitated to push Sphene aggressively, too soft for everyday wear, too visually busy for conservative buyers, too complex to explain quickly. But among serious collectors, Sphene earned a different reputation. It became a test, not of rarity, but of perception. Collectors would examine the stone under multiple lights, then argue about what mattered more. Was the color shift meaningful if the dispersion dominated the experience? Could a gemstone be evaluated for change if brilliance constantly pulled focus away? Sphene forces that argument. It proves that color change doesn't exist in isolation, that light is a system, one behavior influencing another. After the discipline of Spinel, Sphene feels destabilizing. After the personalities of Tourmaline, it feels chaotic. And that's exactly why it belongs here. Because Sphene marks the point where transformation stops being polite. It stops waiting to be noticed. It competes. And as we move higher on this list, the stones ahead won't just challenge what people see, they'll challenge how people decide what counts. Ranked fourth, color change Zircon, the stone everyone thinks is fake. Zircon has a reputation problem. For many Americans, the word zircon triggers an automatic response. Cheap, synthetic, imitation. That confusion has been so effective that most people never stop to ask a basic question. What if zircon isn't fake at all? Because natural zircon is one of the oldest gemstones on Earth. Some crystals date back more than 4 billion years, older than most of the planet's surface. Long before cubic zirconia existed, zircon was already recording geological time. Yet when zircon changes color, disbelief intensifies. Under daylight, certain zircons appear cool, blue, blue-green, or pale teal. Shift to warmer indoor light, and the body color drifts toward golden yellow, amber, or reddish-brown. The transition isn't violent, it's controlled, measured, and for many viewers, that subtlety feels suspicious. That has to be treated. That looks engineered. But the color change in zircon isn't artificial. It comes from trace elements and lattice defects interacting with different light spectra, often enhanced by heat treatment, but not created by it. And that distinction matters, because zircon doesn't pretend to be something else. It simply suffers from the name it shares. Cubic zirconia hijacked zircon's identity, and zircon never recovered. That misidentification shaped American behavior for decades. Collectors avoided the stone, jewelers downplayed it, consumers learned to dismiss it instantly, which makes color change zircon disruptive in a very specific way. It doesn't just challenge what people see, it challenges what they think they know. When experienced collectors encounter a high-quality color change zircon for the first time, the reaction is often quiet, but permanent. They stop associating zircon with imitation. They start associating it with age, density, and optical seriousness. The color change becomes proof, not proof of novelty, but proof of legitimacy. Zircon doesn't compete with sapphire or spinel in prestige. It doesn't need to. Its power comes from contradiction. A stone people were taught to ignore suddenly behaves with complexity and restraint. It shifts color politely. It holds its brilliance. It refuses to apologize. In American gem circles, that reversal has been slow, but real. Collectors who once laughed at the name now argue about hue balance and transition clarity. They debate daylight tones. They compare warmth under incandescent light. And once that conversation begins, the stigma collapses. Because zircon doesn't ask to be rebranded. It asks to be understood. That's why it belongs here, near the top of this list. After Sphene fractured perception, zircon fractures assumption. It proves that the biggest obstacle in gemstone appreciation isn't rarity or science. It's memory, what we were taught to believe, and how hard it is to unlearn it. In this moment, the problem isn't imitation. It's memory, and how hard it is to unlearn what we were taught. Rank third, color change chrysoberyl. Almost the legend, but not the legend. This is where most people get it wrong. They see the color change. They see green shift toward red, and they jump to the same conclusion, Alexandrite. But not all chrysoberyl that changes color is Alexandrite, and that distinction matters more than people realize. Color change chrysoberyl exists outside the narrow definition that made Alexandrite famous. It shares the same mineral family, the same durable structure, the same ability to interact with light in complex ways. What it doesn't share is the historical burden. Under daylight, non-Alexandrite color change chrysoberyl can appear yellow-green, olive, or muted teal. Under warmer indoor light, it transitions, sometimes gently, sometimes clearly, toward brownish-red, coppery tones, or earthy rose. The change is real, but it's not theatrical, and that restraint is exactly why it confuses buyers. For decades, American collectors were trained to look for one thing, a dramatic green-to-red flip. Anything less was dismissed as almost Alexandrite, almost impressive. But that mindset misses the point. Color change chrysoberyl isn't trying to replace Alexandrite. It exists to demonstrate the mechanism without the myth. The physics are still there. Trace chromium interacts with different lighting spectra, altering absorption bands inside the crystal. Daylight emphasizes cooler wavelengths. Incandescent light pulls warmth forward. Nothing artificial, nothing added, just a different balance. And that balance reveals something important. Without the weight of legend, collectors are forced to judge the stone on behavior alone. How clean is the transition? How stable is the crystal? How honest is the color under mixed lighting? These questions strip away expectation, which is why experienced collectors often find non-Alexandrite chrysoberyl more educational than the legend itself. There's no shortcut to admiration here, no reputation to lean on, no instant recognition. The stone has to earn attention. In the U.S. market, this created a quiet divide. Casual buyers overlooked it. Serious collectors leaned in. They understood that Alexandrite didn't appear fully formed. It emerged from the same mineral system. Color change chrysoberyl represents that system without the spotlight. And that makes it unsettling. Because once you accept that Alexandrite isn't unique in ability, only in degree, the legend starts to feel human, built, curated, maintained. Color change chrysoberyl doesn't diminish Alexandrite. It contextualizes it. It reminds us that nature doesn't work in absolutes. It works in gradients. And standing at number 3, this stone serves a very specific purpose. It prepares the mind. Because once viewers understand that the boundary between almost and iconic is thinner than they thought, they're finally ready for the stones that follow. The ones that don't just demonstrate color change, they define it. Ranked second, color change Andalusite. The stone that refuses a single truth. Most gemstones respond to light in one way or another. They ask for a single condition, daylight or indoor light, and offer a single answer in return. Andalusite does not agree to that contract. At first glance, it appears restrained, earthy, olive green, yellow-green, sometimes brownish in daylight. Nothing about it feels theatrical. Then the light changes. Under warmer indoor light, red and copper tones begin to surface. Subtle at first, then unmistakable. But unlike other color change stones, the transformation doesn't settle. Rotate the stone. The colors shift again. Not because the light changed, but because you did. This is where Andalusite becomes difficult to explain. Its color change isn't a simple before and after reaction. It's layered on top of one of the strongest pleochroic effects found in natural gemstones. That means Andalusite doesn't show one color at a time. It shows multiple colors depending on direction, simultaneously. Green along one axis, brown or gold along another. Hints of red emerging as the spectrum warms. The stone doesn't choose a dominant identity. It presents several and lets the observer decide which one to believe. For many American buyers, that behavior felt uncomfortable. They were trained to evaluate gemstones quickly, to look for clarity, saturation, and consistency. Andalusite offers none of those in a clean, reassuring package. Early reactions were predictable. It looks muddy. It can't decide what color it is. Something must be wrong with the cut. Nothing was wrong. The stone was doing exactly what physics allowed it to do. Andalusite's crystal structure absorbs light differently along multiple axes. Change the angle, and different wavelengths dominate. Change the light source, and a different set of colors emerges. Not instead of the first, but on top of it. Collectors who stayed with the stone long enough began to understand its value. Not as a showpiece, but as a demonstration. Color change Andalusite exposes a flaw in how people think about color itself. We assume color is an attribute of an object. Andalusite proves it's a relationship between light, structure, and perception. That realization changed how serious collectors approached it. They stopped asking whether the stone changed color enough. They started asking how well the colors coexisted, how readable the transitions were, how controlled the complexity felt. Because complexity without balance is chaos. Andalusite isn't chaotic, it's conditional. That's why it belongs so close to the top of this list. Not because it's the most famous, not because it's the most dramatic, but because it prepares the viewer for something harder to accept. That color isn't fixed. That observation isn't neutral. And that reality can look different depending on where you stand. After Andalusite, the audience is no longer watching gemstones change color. They're watching themselves interpret change. If this already feels difficult to describe, the stone that comes next won't simplify anything at all. In first place, Alexandrite, the stone that redefined color itself. Alexandrite doesn't introduce itself. By the time it appears, the audience already knows what to look for. They've seen stones respond to light. They've watched colors shift, overlap, hesitate, and compete. Alexandrite does none of that. It decides. Under daylight, a fine Alexandrite appears green, sometimes bluish green, sometimes cool and restrained. Bring it under warm indoor light, and the color doesn't drift. It crosses a line. Green becomes red, not brown, not purple. Red. The transition is so complete that many people assume they're looking at two different stones. They aren't. This is not pleochroism layered on top of color change. This is not branding. This is not narrative. This is physics aligning perfectly with perception. Alexandrite's crystal structure contains trace chromium that absorbs and releases light with extraordinary selectivity. Daylight emphasizes shorter wavelengths. Incandescent light reveals longer ones. The result isn't subtle, it's categorical. And that categorical shift is what made Alexandrite legendary. When it was first discovered in the Ural Mountains in the 19th century, the stone immediately disrupted everything gemology thought it understood. Not because it changed color, but because it changed identity. Most gemstones adapt. Alexandrite transforms. In the American imagination, that transformation took on a different meaning. Collectors didn't just admire the color change, they trusted it. Because Alexandrite behaves the same way, again and again, under the same conditions. No hesitation, no ambiguity. That reliability elevated it from curiosity to benchmark. Every color change stone that followed was compared against Alexandrite, often unfairly. How close does it get? How red is the red? How green is the green? But those questions miss the deeper point. Alexandrite isn't important because it changes color best. It's important because it changed how color was defined. Before Alexandrite, color was treated as a property. After Alexandrite, it became conditional, depending on light, depending on environment, depending on context. That idea now underpins modern gemology, optics, and even display technology. Alexandrite didn't just influence jewelry, it influenced how humans understand perception, and that's why it sits at number one. Not because it's rare, though it is. Not because it's expensive, though it often is. But because Alexandrite closes the loop. After Fluorite taught us to notice light, after Hackmanite taught us that stones can remember it, after Andalusite taught us that observation changes outcome, Alexandrite delivers the final lesson. That color is not what an object is. It's what reality allows you to see. Alexandrite doesn't ask you to believe. It shows you. Alexandrite doesn't prove that stones can change color. It proves that color itself was never fixed. And once that idea takes hold, nothing you've seen in this list ever looks the same again. By now, it should be clear that these stones weren't just changing color. They were changing context. Light shifted, perspective shifted, and with it, the meaning of color itself. Some stones reacted subtly, others transformed completely, but each one revealed the same truth. That color isn't fixed. It's conditional. And once you start noticing that, gemstones stop being static objects. They become conversations between light, structure, and perception. If this journey changed how you see color, even slightly, then you're already seeing gemstones the way collectors and scientists do. And if this is your first time here, this channel is where we explore the stories hidden inside the earth, the ones most people never notice until someone points them out. You don't need to like, you don't need to comment, just stay curious, because the next stone we explore might already be changing right in front of you.